So let's start the second part of the series of the sessions on operating system. So here in this session we will try to dig up more about what exactly the Linux operating system is all about. So here in this session we will be dealing with to understand what is the kernel, followed by Linux kernel subcomponents, what are the components of it, and we will try to understand its functionality like process scheduler, memory management unit, virtual file system, network subsystem, IPC and so on. Then we will try to understand Linux library, files and directory, then the directory structure of the Linux operating system. Then we will try to understand the shell in Linux and its different types. Finally, we will try to understand Linux command and its structure. So, with this understanding, you will be able to start the journey to understand the operating system and its functionality. So, let us start. So, in the last session, we have seen that from the user perspective, how the application runs on that particular device or on that particular system. That application goes through the operating system to the hardware, and hardware process that particular program and gives back to user, right. And when we talk about the operating systems, there are different parts of it like shell, system libraries and kernels. So, in this session we will try to debug more about what each component consists of, starting from kernel. So, here we will try to understand what exactly the kernel is, and then we will try to understand the subcomponents of the Linux kernels. What is basically kernel? Kernel provides a platform for programs and various services to run on top of it. It means that kernel is the intermediate thing from the application perspective and the hardware perspective. So, it acts as a bridge between the software application and underlying hardware of the system. It is responsible for managing system resources, handling the hardware communication and ensuring the smooth execution of the process. It means that if you try to run any application or any code on the computing platform, kernel is responsible for making it run on the hardware and giving the result back to you. So, while running that application on the system, different steps are involved, like allocating the resources, then maintain the communication between the different tasks and giving back results to the user. So, all these tasks are basically performed by the kernel, and kernel is responsible for managing all system resources. Basically, kernel follows a monolithic kind of architecture. Monolithic architecture means that from the hardware perspective, kernel runs as a single large process with the highest privileges. So, from the hardware perspective, there is one single process which is managed by the kernel, and for the different upper layer applications or the codes, kernel manages those things for the different processes by creating different machines called as the virtual machines. Basically, it supports loadable kernel modules, LKMs, allowing dynamic addition or removal of features. This is one of the very the important feature of Linux kernel, and this gives the flexibility to have the variety of flavors of Linux operating system. As we have seen in the last session that Linux operating system possess variety of flavors like a Fedora, Archie, Debian, so and so. So, this particular feature makes it possible to add some or remove some features from that user perspective. So basically what kernel does on the system, it actually virtualizes the computer's hardware resources with its own virtual resources. It means that from the kernel perspective hardware is one, and from the application perspective there are like different virtual machines or virtual resources available. So that each application feels that okay, that particular hardware is totally dedicated to him only. So let us try to understand that aspect. So if consider that on the one particular system there are 3 applications running on, and every application consists associated with one process, okay, and let us say there is a hardware. So generally what is needed, okay, that every process will be spawning some request on the hardware to perform its own task, but in general these processes, these high level language codes cannot directly run on the hardware resources, because the applications which any user writes, that generally is in the form of high level language, but hardware only understand the low level language or in bit binaries only 1 and 0 language. So there should be someone who translates those things, okay, to the hardware, perform the task and give back result to the respective applications or the respective users. So directly high level language codes cannot run on the hardware resource, right. So there should be someone who is seated in between these high level applications or the processes and the hardware, and he should do the handshaking, proper communication and management of all these programs or the requirements. So kernel, as we have seen that particular operation or that particular task is performed by operating system, and in the operating system as well the kernel is one of the main component who manages all these things. So from the, as I said, so kernel spawns one single process on the hardware with the highest privileged. So from the hardware perspective kernel is running in a single instance, right, but from the user's application perspective, so for every process it creates one standalone single virtual machines associated to that process, and the kernel manages the communication between these processes or switching of these processes in between, so that every process should get the access of underlying hardware. So every process feels that okay, he is getting the full control of hardware, he also gets the full control of hardware, he also gets the full control of hardware. So all these communication or all this context switching is done by the kernel. So kernel plays a very important role in this aspect, and this is the reason kernel is a very vital component of an operating system. So it removes the complexity of handling the hardware resources from the user perspective. So let us try to understand how this particular kernel manages these things. So what are the different subcomponents of this kernel? So there are so many components which helps this kernel to accomplish all these tasks. So very first is the process scheduler, which is actually responsible for managing the process related tasks like switching of the process, okay, managing the process IDs and everything, allocation of the resources to that particular process, deallocation and so many things, right. Then there is a memory management unit, that is also the part of kernel, okay, subcomponents of kernel, which is responsible for managing the memory related task. Third one is the virtual file system. This, as I had mentioned, so as soon as another process comes, so kernel creates one virtual machine for that particular process. So this virtual file system is responsible for all those tasks. Then another important component is the network subsystem, which manages all the network related aspects of the operating system. Then there is a inter-process communication unit, IPC unit, which is responsible for communication of the process if they want to communicate among themselves. So, when it is aspect of working on multi-core kind of the system or high performance computing kind of system. So, there are so many processes running on that particular system, and in between they need to have the communication. So, these particular features of the operating systems helps to develop high level programming models, which internally will like take the advantage of these features, and they can write parallel programs to run on a single like big machines having the multi core kind of resources available with it. So, I hope you understood the basic concept of the Linux, how actually it performs the crucial role in the operating system. Now, let us try to understand some Linux subcomponents of the Linux operating like Linux kernel. So, very first is the process scheduler. As I had mentioned earlier, it is basically responsible for managing how the processes are allocated to the CPU resource, and its primary goal is to maximize the CPU utilization. So, that maximize the CPU utilization and ensure the smooth multitasking. So, that whatever the available CPU time, that CPU time share should be divided among the different processes equally. Okay. So, that is the main task of this particular process scheduler. When we talk about the key elements of this process scheduler, there are so many, like there are some scheduling policies, right. So, different scheduling policies are available like round robin, first come first serve, shortest job next. Okay. So, as per the demand and as per the requirement, okay, this particular process scheduler applies that policy for that particular job. Also, it is responsible for showing the status or managing the status of the process, like when to put it into the running state, waiting state as per the priority signals. It try to deal with all those aspects of the process states. Then primitive versus non-primitive scheduling. So, what is mean by primitive and non-primitive case? Primitive case means that, okay, if one particular process is running on the CPU, and in between if high priority signal comes in or high priority process comes in, we can retrieve the CPU resource allocated to that particular process in case of the primitive. But in case of like non-primitive scheduling, if CPU is allocated to that particular process, so the CPU will be deallocated only when that particular process is completed. So, all the aspects regarding managing all these features and everything is the part of process scheduler. Then context switching, switching from one process to another process to have the fair share policy or regarding the hardware resource utilization is the part of the scheduler, and balancing the load is also one of the crucial aspect of process scheduler of the Linux kernel. So, when we talk about the memory management unit, okay, it is basically responsible for efficiently managing the memory resources available, that is physical as well as the virtual memory, as well as mapping the physical memory to the virtual memory and so on. So, that every like a process gets fair amount of memory to perform their task. When we talk about the key elements of MMU units, it is the like address translation, like mapping from the virtual to physical memory and physical to virtual memory, vice and versa, managing the page tables, then having the like creation of like a TLB translation look aside buffers, which actually is a part of the memory with a very small in size to store a recent data. So, management regarding this TLB is the part of memory management unit. Then memory protection, cache control, all these aspects are taken care by the memory management unit of the Linux kernel. When we talk about the virtual file system, Basically it is an abstraction layer that allows the Linux kernel to interface with the different file systems in a uniform way. As we have seen that with every single process there is standalone one virtual machine is created. So the task regarding that creation and everything is basically a part of this virtual file system subcomponents of Linux kernel. So when we talk about its key elements, it has a super block which represents an entire mounted file system. Then there are like index nodes which stores the metadata about individual files or the directories. Then directory entries which represents the directory entries which what files are presented in those directories and so what exactly the directory, what exactly the files are. So all those things we will try to see in the upcoming slides. Then it is also it also deals with the mount points where the file systems are mounted, then different file operation related things, what are the different types of it and so things. So all these aspects are basically managed by the virtual file system component. Then another part is the network subcomponent. Basically it manages the communication between the devices over a network. It is responsible for processing, routing and managing all network packets as they pass through that particular system. So when we talk about the different like key elements of it, okay, like a socket APIs, interface between the user space applications and the kernel, managing the different protocols like a link layer from the Ethernet, Wi-Fi, right, network layer as well as link layer as well as transport layer, application layer. So managing all those things is the part of network subsystem. Then managing the network stack, network devices, packet processing, routing, traffic, all these are aspects and the key elements of the network file subsystem of the Linux kernel. Then IPC is also one of the important component of kernel which actually manages the communication and synchronization between different processes which are running on that particular system. Basically it manages those things, how takes the collaborations between the multiple process and whatever the shared resources are there on the system, how those shared resources can be efficiently processed, can be efficiently accessed by the different processes on that particular system. So all those components with respect to inter-process communication, see this particular IPC units takes care of. Like these are the key components of it, like message queuing, allocating the memory. Basically on like a single node kind of system there is a shared memory among the different process, okay. So managing those all aspects is the part of these IPC units. So these are all about the different components of kernel of a Linux operating system. So by combination and utilization of all these, so all these are the components of Linux kernel which in synchronization makes the Linux kernel very efficient and usable from the system as well as the user perspective. So all these components are basically responsible for kernel to work efficiently. So now let us try to understand the Linux library files and the directory structure, another important aspects in the Linux operating system. Basically in Linux everything is file. So either you take any directories or any device. So Linux from the kernel perspective it treats as a file to everything. So as I had mentioned, in Linux most system resources and devices are represented as a file. So when you connect any device as well, so from the operating system perspective it is nothing but a file only. So this abstraction simplifies the interaction with the various components of the system, and actually this is one of the main feature of the operating system which makes it more simplified operating system in the categories of different OS. And when we talk about the system libraries, which are actually the essential components that provides like commonly used function and services in a uniform way. So it try to create a standard way of dealing with the Linux components. Basically, Linux libraries are shared by multiple applications, making them highly efficient in terms of memory usage and execution speed. So let us talk about the different types of file in Linux. So very first is the regular file. So regular file means like normal text files, binary files or scripts by which we can write some data, we can save that particular data. So those are like a regular files. Now talk about the another type of files, which is the directories. Basically directories themselves are a file which actually contains or holds the information about the other files. So when we try to compare this like concept with Windows, then like when there we try to talk about some folders. So one folder consists of another folders or maybe the files. So similarly, here are the directories are nothing but the folders which actually contains some other files or directories. Another type is the device. Okay. So in case of the Linux operating system, devices or the interconnected peripheral devices like keyboards or mouse, those are also actually treated as the files only, and all the corresponding files are actually stored in the hyphen device directory. We will try to see the different directories when we try to understand the different when we try to understand the directory structure of the Linux operating system. Then there is like another types of files like a symbolic links, okay, is also the file that points to another file or a directory. Then network interfaces like Ethernet or LAN, okay, those are also actually treated as the files only within the Linux. So in all cases mostly everything is file in Linux, but there are like few exceptions, like few concepts basically that strictly does not apply the file concept to process threads or memory, but other than that in Linux everything is about the files only. So as of now we try to understand that, okay, what is Linux and what is actually the Linux operating system and specifically the kernel. We try to understand the different components of subcomponents of the kernel. Then we try to understand the files and its different types in the Linux operating system. In the next sessions, okay, in the next part, we will try to understand the directory structure and followed by the structure of Linux commands. Thank you.